next talk by Christophe Philemotte. You can say his last name for you if I said it wrong. The talk is titled Build a Cross-Platform API CLI in 15 minutes with mruby-CLI.
Sorry, my computer just froze.
That's a good idea.
But maybe the start of time might.
No, start time is fine.
That's
It's for like 2 hours. Here's about 10 minutes start time. The start time is going to be 3 minutes. Hey, Mark, huh? We'll have 3 servers with you.
It's okay, give people a chance to get coffee.
I think it will work very well. Let's grab Charles.
working on good job.
Yeah, let's get him.
I hope everyone here was able to sign up for the raffle. Yeah, forgot about it. Is it still open? Yes. So if you haven't, please go sign up. After this talk, there's going to be a break.
The questions are pretty easy.
Finally, excuse me for the delay. Maganangaro Akosi Christophe. I'm from Belgium. I'm the founder of Code Review. It's an automated code review service for Ruby and Rails, a little bit like Climate. I'm a software engineer at Euronova, a private R&D service company. I'm also president of the association Ruby Belgium, and we do a lot of stuff there. And it's a real pleasure to be here today. Not only because I have the chance to see a lot of friends and new ones, but because I had the opportunity to participate to the Underwater Ruby event with Chris, Sam, Joy, Simone, and my wife Odile. And you have, I can tell, wonderful waters here. So I hope that the next time I will see you there. Today I would like to talk about a project I contribute to, which is mruby-CLI, and how you can build CLI for Web API with it. So when you have a web app today, it's not just a simple box. You will link it with a lot of third-party services, such as GitHub or for emails, SendGrid or Mandrill and Google Analytics for analytics and so on, because they do one thing very well. And to interact with those third-party services, you need to work with their web API. And there's a reason why when you look for the Google Trends of the keyword web API, it's really rising because people are using more and more those web APIs. But as a developer, when I want to interact with all those development tools that are third-party services and have a web API, such as GitHub, Heroku, or Travis CI, the browser is not really a good option for me. Indeed, I spend most of my time into the terminal, and I don't want just to play with the browser. So when you provide a web API or you want to work with one, building a CLI, a command line interface application, it's a good good option, especially if you want to do a simple task or even a complicated one. But when you provide those CLI, you need to deploy them. You need to deploy them on your users' computers, and they have different environments, different platforms, and it's not easy to provide all those specific binaries for all those platforms. So when you need to do that, there's a couple of ways to achieve that. One way is to build your own cross-tool chain, but it's something very poorly documented, and it's not fun at all. So yeah, I would prefer a better solution, not to spend like 1 month just to be able to compile my project. So you can use jar files, but the problem with jar files is that you need to have the JVM pre-installed on your user's computer. So it's not a good option either. You can use dynamic language such as JavaScript. What you can know, JavaScript. Python then? Yeah, I know, we are at a Ruby conference, so let's talk about Ruby. And it works, right? But the fact is, job aside, all those three have the same issue. And to illustrate that issue, let me talk a little story about the RubyConf toolbar. So at first it was written in Ruby, and you just have to install a gem to use it. But as a maintainer, RubyConf had to maintain a lot of different Ruby versions. But not only different Ruby versions, different platforms too, different environments. And you are not even sure that everybody has the same gems installed on their machine. So as a maintainer, the only thing you can do is despair and cry. When Go arrived, it came with a great toolchain, cross-compilation toolchain. So with Go, you can compile different binaries for different platforms, for different architecture, and it's a really good option for that. But is it the right tool for that? Maybe. And in fact, RubyConf did that for their new tool belt. They have totally rewrote the whole application in Go. And they have removed the Ruby dependency. But I don't think Go, in my opinion, is a very good option. At least I think Ruby is more expressive and a better option to write a CLI application. And as Steve Clackman said, and I quote him, I don't mind anyone switching languages. Different languages are awesome. But if you love Ruby and want to keep writing Ruby, then being aware of Ruby's weaknesses and how to shore them up so you can keep writing more Ruby is important. So in other words, it's not because Ruby doesn't have that feature that we should stop them. Here comes mruby-CLI. mruby-CLI is a framework to build CLI application that you can deploy on any platform and architecture thanks to Docker. So the goals of mruby-CLI is to write CLI application with Ruby, to get good performance, to not rely on require, to have a binary for each platform and architecture, to be simple to compile and release. To summarize, it's a framework to build CLI applications such as Rails. It's a framework to build web application. If you want more detail about the design of mruby-CLI, you can look at the last Terence and Zach talks about that at RubyConf. They cover all the details about that. So let me quickly explain the project. So the project was created by Terence and Zach, and I joined recently. I joined the team in order to work on different features such as packaging or a better handling of options. So mruby is a new Ruby that Matt has started to be light and easily embeddable. It complies with the ISO standard of Ruby. It's compatible with the Ruby 2.1 Core API. Because because you want to be light and simple and portable. There's no built-in file, socket, or I/O, but you will find them in specialized mruby gem. For the sake of simplicity, you don't have any thread safe or thread class, but you can still use procs, blocks, you can do metaprogramming, you can even do monkey batching, you can use literals, and it's easy to bind your mruby program with any CLI compatible library, and even C++ API library. There are a few gotchas that you need to be aware of. There's no standard library, but you have a lot of mruby gems providing you the feature you're looking for. If you use some native extension, you need to be sure they are ready to be cross-compiled. And there's no Ruby gems until now. We're talking about that, but there's a very simplistic version, which is a list of all the available mruby gems. So, what's a mruby program? An mruby program is a compiled binary composed of different pieces. So you have the mruby bytecode, which is your mruby source code compiled. Then you have an mruby VM to run that bytecode. Then you have the compiled C and the compiled libraries. And if you want, you can also keep some links with dynamic libraries, but you are not, you don't have to. So it's probably the mruby program has nearly zero dependency. So it's very easy to deploy. So let's talk about Docker. The mruby doesn't provide you an easy build system in order to cross-compile your application. But mruby-CLI does that for you thanks to Docker. So it works as following. On the left you have your source code, C, mruby, or even C++ files. And then in the middle, you have your Docker container with all the needed tools and libraries in order to cross-compile your application. And it will generate different binaries for each platform, Windows, OS X, and Linux, and for the two major architecture, 32 bits and 64 bits. So let's do some live coding safely. I'm cheating a little bit. So, a little bit like Rails, you can create your application, CLI application with mruby-CLI, and then you obtain a bunch of files. So here you have all your, in the mruby-lib directory, you have all your source code, mruby source code. Then you have your bin test to test the behavior of the binary, the mruby test, usually unit test, the file for Docker, the config of your build, and then mruby-gem.wake, which is a kind of gem spec for mruby-CLI application. So let's get into the directory of the application, open the source code. So what we want to do is to output hello RubyConf Philippines 2016. So I changed the default code that was generated. And then I can go back to the terminal in order to run the compilation. So I do docker compose run compile, and then it starts to compile. So the first thing it does is downloading a lot of stuff like mruby and all the mruby gems. It can take a long time, so let's update the test. So we want to be sure to test that we output hello RubyConf Philippines. And in the mruby test, there's a default one, but because we don't have a lot of code, we can keep it as it is. Let's go back to the compilation. I'm speeding it up a little bit. As you can see, there's a lot. And then you get a summary. In the summary, it lists for each target the dependencies you have. So here you have the sprintf, the time, and so on. And then also the resulting binary, which is your CLI application. And then you have that for each target. Linux, 64 bits and 34 bits, OS X, and so on until Windows. So now we can run the test, Docker Compose run bin test, and then it succeeds. We can run the mruby test, and it succeeds too. And you can even release your application by doing Docker Compose run release, and you will obtain a compressed archive for each target. So let's continue. So because mruby-CLI application have a lot of common, such as the way you handle the options, the help message, the version, and so on, we started to work a more advanced scaffold, and I will show you that now. So you will see there's a bunch of new files that were in there. So you have the option, the handling of option, to print the version, to print the help message, and then you have the CLI.rb file, which is like your main controller or your main application. It's the entry point of your application. Let's open that. So you see there at the beginning, you create the options, you browse them, and then here in the run method, you implement the way you want to handle the different options. So when we get version, we'll print it and so on. So let's continue. Now I want to show you a real example, which is a CLI application to work with a web API, which is the goal of that talk. So a little disclaimer, I lied a little bit. It won't take me 15 minutes, but less. So here the use case. I'm in a local working copy of a Git repository on a specific branch, and I have earlier created a pull request for that branch. And I would like, in my terminal, get the GitHub status of that pull request, such as I type GitHub status and obtain if it's a success or a failure, or if it's just pending because there are no GitHub status. We need to know a few things before doing that. First, we need to know which repository it is. We can do that with the git command and obtain the URL of the remote repository, like here. We need to know the name of the current branch. Again, we can use the git command for that. We need to find the corresponding pull request, and for that we will use the GitHub Web API. So what you have is for a given repo, you want all the pull requests, and you can filter them in order to keep the current branch, the one you work on. And then you want to retrieve the GitHub status for a given pull request. The way you can do that is having the shard of the head commit of that pull request and request the status for that commit. So, oops. You create your CLI application. I call it GitHub status. You see all the generated file. I go into the directory, and then I will do first a couple of things. First, I will disable all the build for the other targets in order to speed up the compilation. Probably will take a while. So I will keep only the default one for the host. Then I will add some dependency in my mruby.rake. So I want to exit my application with some error codes. I want to deal with HTTPS connection, so I hide mruby-gem Polars SSL. And I want to play with a web API, so I add that mruby-gem web API. Then I can update the name of the order of the application and so on. So here it's a quick fix. So this is a rig file containing all the rig tasks that you can run in your Docker container, so like compile, test, release. Then here it's a very quick fix because the upstream mruby has a bug and we had to deal with that, so it's just a quick update of that mruby dependency. And then we can go back to the terminal and run the compilation. So as you see, first it downloads mruby and then all the mruby gems and so on. So let's talk about the application itself. So you see here the summary of the compilation. Let's open the codes. That's the dependency, the resulting binary. And here you have the code. So here it's the default one, and I will update it with the one I need. So I add some code. So first you have the exit on error method that will output a message and exit the program with a given error code. And then the sequence of instructions that will allow me to retrieve the GitHub status for the corresponding pull request. So first we get the repository name, we check if it's hosted on GitHub. Then we extract the name of the repository. Then we do the same for the branch. So we retrieve the current branch, we check that it's not detached. If it's not the case, we extract the branch name. Then we can create the API client. So we need to define the host, api.github.com. We need to provide some header, like we accept JSON. We need to also define the user agent, or the GitHub Web API will complain. Then first we define the URL to get the pull request. So we pass first a hash with the resources and the IDs. So I want that repository, and on that repository I want all the pull requests. And among those pull requests, I want to keep only the one that corresponds to that branch. Then I can request that URL and get the JSON response. If it's empty, it's because there are no pull requests, and I get an error code. If it's not empty, I can get the SHA of the head commit, and then I can build a URL to get the status of that commit. So again, the resources and the IDs, or the repo, the SHA of the head commit, and then I want the status for that one. And then I get the JSON response, and I can print it. So let's check what it does give you. So I've created first a pull request on a branch called test all targets. And as you can see, the GitHub status is a success. So if we go into the terminal and we test that, request the GitHub status, and it gives you a success. So that ends the talk. I think we have now, with mruby-CLI, a good option in order to build CLI for CLI application, especially to build CLI for Web API. in Ruby. You will find mruby-CLI on the Terrance repository, the mruby gem for Web API online, and the example I just showed you on the other repository. Thank you for your attention. If you want to build a CLI for your Web API or any Web API, just talk to me during the break. And if you have any question, I think that there are some time, or you can always talk to me during the break or on Twitter. Thank you very much.
Not really a question, but another testimonial. JRuby, our native launcher, our native executable, that when you run JRuby, that's what you actually execute. With JRuby 9.1 release, it's going to be an mruby application. And we've been working with some folks that there's a mruby JVM that you can actually write launchers for any JVM application using mruby and compile it down to a native binary. So it's really slick, and we're convinced enough that we're going to have that be our standard launcher from 9.1 forward.
Awesome. Thanks. Other question? No? Okay. Time for the break.
Yeah, thank you.
Thank you.